All right, like I said, 9.4 logarithmic functions. So first of all, I'm going to show you some notation we use for logarithms. So y'all, I got log subscript x of y equals b. So logarithm notation, the x, we call that the base. Y is the result. And b is the exponent. So when you see log notation, what log notation is going to do, it's going to figure out what exponent this base has to be raised to get that result of a y. Okay, so basically a logarithm finds the exponent that the base was raised to get that result. So you can almost think of them as a way of undoing exponential equations, okay? So if I know what base I'm using and I know what that result is, then these logarithms will find those exponents, okay? So just remember, this log expression is finding exponents. So I'm going to do a few examples to get you used to this logarithm notation, okay? So if I got log base 5 of 25, so what this expression is going to find me is what exponent would I raise this 5 to get me a 25. So y'all, let's think about it. So 5 times 5, if I multiply 5 times itself 2 times, that'll get me 25. So that means the exponent that this would find would be a 2. Okay, so 5, my base, squared equals 25. Okay, you also remember we're finding exponents with these. So if I had a log base 3 of 27, so I'm looking for what exponent would I raise 3 to get 27. Well, if you started with a 3, 3 times 3 would be 9. 9 times 3 is 27. So since I did that 3 times, my exponent would be a 3. So 3 to the third power equals that result of a 27. All right, how about a log base 2 of 32? All right, y'all, so let's see. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. And then 16 times 2 equals 32. So let's see, I did that 5 times. So that means 2 to the 5th power equals 32. So that exponent would be a 5. Now, y'all, let me do a couple more of these. How about a log base 5 of a 1. So there's only one exponent that I can raise a 5 to get a 1, and that exponent would be 0. So no matter what base you have here, actually, no matter what base you have, if that result is a 1, then that exponent has to be a 0, okay? Because anything to the 0 power is 1. All right, one more and then we'll move on. So log base 7 of 7. So what exponent would I raise 7 to get a 7? Well, that exponent would be a 1. Okay, so like I said, logarithm notation. Your base is the subscript, your result, and that's going to find you the exponent, okay? Now we got two special logs, and these two are on the front of your calculator. One on the calculator to the left of the 7 is a log. We call this the common log. And if you see a log like this that does not have a subscript by it, that is a log base 10. So remember, if I don't have a subscript, it's automatically a 10. Any other number like the 2, the 3s, the 5s, you got to physically write them on here, okay? But like I said, this is the common log, and it's always a log base 10. And then we have another one on your calculator to the left of the 4. And this is the LN, and this is what we call the natural log. And y'all, a natural log is actually a log base E. So that Euler's number we learned last week is the base of the natural logs, okay? So y'all, what I'm going to get into now is comparing these graphs to the exponential. So we'll look at graphing logarithmic functions. So the first thing, these logarithmic functions are inverses of the exponential graphs we looked at last Thursday. So all the exponential graphs went to 0, 1 on the y-axis. Well, all the logarithmic functions, they go through the point 1, 0 on the x-axis. So they go through the point 1, 0 on the x-axis. That's because anything raised to the 0 power equals 1, okay? All right, let's see. The domain of a logarithmic function is from 0 to infinity. Now, it can't equal 0. That's why I got the curvy parentheses here. So if you notice, it includes all the positive x values. There's no negative x values. And that's because there's nothing I can do to a number using the exponent that can change the sign of those numbers, okay? And then the third property is they create a vertical asymptote And they have a vertical asymptote at x equals 0. So the y-axis basically is where x is 0 at. So that means they're not going to cross over that y-axis. They're just going to make an asymptote by it, okay? So let me show you the shape of our exponential graphs we did last week. So exponential. Let me put that down just a little more. So remember, exponential graphs were the ones where we had y equals a to the x. So the exponentials went through 0, 1, and they sort of came up, went through there, and went up. So they make a horizontal asymptote to the x-axis, but it'll never cross over. Now our logarithmic graphs, the logarithmic graphs go through the point 1, 0 on the x-axis. They make a vertical asymptote. So what they're going to do, they're going to sort of come up along that y-axis, go through that point 1, 0, and then they just sort of rise toward infinity, okay? So notice they're sort of opposite of these, and that's because these are inverses of each other. So this is our logarithmic. So this would be y equals log of x. Okay, so notice no graph on the left side on the logarithmics. Okay. All right, y'all. So I'm gonna show you some of these on the calculator real quick. Now we don't have to physically graph these on MATLAB. You're just going to pick out a picture on them, okay? So they want us to graph f of x equals log of x. All right, y'all. So let me share my calculator. So I'm gonna go to y equals. So log is right here by the 7. So hit in, and then we put in our x, and then I'm gonna close parentheses. Now I want you to see the table first so that you can see that these negative x's when I come up here are going to give me error messages. Okay. So we can't take a log when the x's are negative. Now let's look at the graph. And it's hard to tell, but it's coming up that y-axis and curving over 1, 0, and then heading up towards the right. Okay, and they'll have 4 pictures, one coming up right, one will go the other way, and then they'll probably have a straight line or something else like that, okay? Let's graph this one. Let's graph f of x equals the ln of x. So the ln is also on the front of that calculator. So I'm going to clear that one. ln is down here by the 4. So I'm going to hit the ln and put in my x. And y'all, let's hit graph again. So that's a little easier to see, but you can tell how it's going through the 1, 0 on the x-axis and then sort of curving to the right. So all my logarithmic graphs will have the same basic shapes, okay? All right, so y'all, that's the trick on go to y equals and graph them. Now notice these are logs. This is the common log since it don't have a base down here. I'm about to show you how to find logs on the calculator when the bases aren't 10, okay? So for these examples, they want us to find the logarithm. So these will start at 4. So for 4, I got log base 5 of 125. So I'm looking for the exponent that I would raise this 5 to get me a 125. So you can multiply that out. So 5 times 5 is 25. 25 times 5 is 125. So since I did that 3 times with the 5, that means that exponent would be a 3. Okay. Now, let me show you on the calculator, because like I said, the log that's on the front of it by the 7 is a log base 10. So when you got another base than a 10 or the E, let me go to my calculator. I'm going to quit this screen. So what we're looking for when we hit the math button over here is log base. So I'm going to hit math. I'm going to arrow down till I find log base. So there's log base. So I'm going to hit enter. And y'all put in your 5, which is your base. Your result was a 125. So now when we hit enter, we'll have the exponent that turns that 5 into a 125. And y'all, there we go. It is a 3. So we can use the calculator for all these logarithm problems. Let's try 5. This is a log base 6 of 36. Oh, y'all hang on 1 second here. All right. All righty. So what exponent would I raise 6 to make that a 36? Well, we got a calculator. Hit math. Arrow down to log base. Hit enter. So my base was a 6. My result was a 36. And y'all, when I hit enter, I get a 2. So that basically means 6 times 6 is 36. Okay. All right, y'all, log base 10 of 10. So check this out. What exponent would I raise 10 to make it a 10? Well, that exponent would be a 1. In fact, there's a property that says the log base A of A equals 1. If that log base matches that result, then the log will find me an exponent of 1 every time. All right, all 7. Log base 3 of 1 over 81. Let me tell you, when you got fractions, those exponents are going to be negative. So y'all, let's punch that one in on the calculator, because that's a little trickier looking for us. So we'll hit math and go get that log base. All right, so that was a log base 3. My result was a 1 divided by 81. All right, so let's see. So basically, we just need to see how many times 3 has to multiply to get to 81. Because since the 81's under that 1, we know it's going to be a negative exponent. So when we hit enter, we get a -4. So y'all just remember, fractions will give us negative exponents on those, okay? A ln of 1. Hey, y'all, so remember, ln is on the front of our calculator. So if I go to my calculator, on the very front by the 4 is the ln. So hit ln and then put in that 1. But y'all, we done said that we know anything, no matter what the base is, if that result is a 1, then that exponent has to be a 0. Okay? And y'all, that gives us another little property about these logarithms. The log base A of 1, no matter what this number is always going to have an exponent of a 0. So y'all, if you notice, most of this stuff today is pretty much getting you good with the calculator on these, okay? All right, y'all, log of 1/10. So remember, this is my common log. Since it don't have a base here, I know that that would be a 10, okay? So the common log is also on the front of our calculator. Also, y'all notice that's a fraction. So since that's a fraction, we know that this will be a negative answer. So y'all, there's my log on the front by the 7. And then I had 1 divided by 10. So let's hit enter on that, and we get a -1. All right, moving on to number 10 now. Log base 7 of 7 to the 5th power. So look at that problem. Log base 7 of 7 to the 5th. My result is a 7 to the 5th power. So what exponent would I raise that 7 to make it look like a 7 to the 5th power? Well, y'all, let's go ask our calculator. And then y'all start seeing a pattern on these. So I'm going to go to math, go down to log base. Because remember, my base on this one is a 7. So I put in my 7. Arrow over to my result. That was a 7 exponent 5. All right, y'all, so watch this. When I hit enter, it's obvious I have to get a 5 out of that. So I would raise this 7 to the 5th power to make it look like a 7 to the 5th. So y'all watch this little property. When I have a log base A of A to the X, if the base matches the base of the result raised to an exponent, then the answer will always be that exponent. All right, y'all, a log base 5 of the cube root of a 5. Now I can finish this in just like it looks, but I want to show y'all a little property about these radicals. So we're going to recall. So a radical, these radicals can be written as exponents, okay? So you take the base, which is the A. To rewrite this radical as a fractional exponent, you put 1 on top, and then whatever number's in that index goes to the bottom. So that this nth root of A can be rewritten as A to the 1 over n. Okay? So let me show you what I'm going to do. Now, I'll punch it on the calculator like it looks right here. But I want y'all to see what this cube root of 5 turns into. So this will be a log base 5. This cube root of 5 turns into 5 to the 1/3. Well, y'all look at that. I got this pattern going on. My base matches the base of the result raised to an exponent. So remember, the answer has to be the exponent of a 1/3. But I'm going to punch it in the calculator like it looks right here, okay? So I'm going to go to my calculator. I'm going to go get log base. So math, go down to log base. Hit enter. My base was a 5. And then I'm going to arrow over. Now for the result, I got a cube root. Well, y'all look at this. To get a cube root, you hit math. And number 4 is a cube root. Now, number 5 will let you do the other roots with that X in front. And I'll show you how to do one of those later. But for a cube root, I hit enter. And underneath was my 5. So if y'all look, I got log base 5, cube root of 5. So when I hit enter, I get 0.333, but we need to turn that into a fraction. So I'm going to hit math and enter twice. And there is our 1/3, okay? So, the logs aren't bad. You just got to think about them as being exponents, okay? All righty. Log base 10 of 10 to the -5th. All righty. So the base of my log matches the base of the result raised to an exponent. So we know this answer will be the exponent of -5. All right, then look at this one. Log base 8 of 2. And y'all look here, the result is smaller than the base. So when that result is smaller than the base, you're going to notice that you get fractional answers for those. So y'all let me share my screen. I'm going to go to my calculator. I'm going to hit math, and I'm going to go down to log base. I'll hit enter on log base. So my base was an 8. My result was a 2. So when I hit enter, I get 0.333. But remember, we need to turn that into a fraction. And that gives us 1/3. All right, y'all, let me turn over here. All righty, so get my paper better here. All righty, so 14 log base 23 of 1. So remember, I'm looking for the exponent that I would raise 23 to turn it into a 1. Well, y'all remember what we said? We don't care what the base is. If that result is a 1, then the only exponent that'll turn any number into a 1 is a 0. So remember, you can check these. 23 to the 0 power equals 1, okay? Now, y'all try this. ln of e to the negative 5th. All right, we got the ln key on the front of our calculator. So I'm going to go punch this in on the calculator. Although we know what that's going to be. So let me clear all this out. So ln is on the left side of the 4. So hit ln. Now to get the e with the exponent, I'm going to hit second ln. So there's that little blue e to the x. Now my exponent was a negative 5. But remember, ln is a log base e. So I really got a log base e of e to the negative 5th. So y'all notice since my base matches the base of that result, my answer will be that exponent of a negative 5. All right, y'all try this one. ln of the 5th root of e. So I'll show you 2 ways to do this. First way, I can punch it in on my calculator where it looks like that. The second way, I can take that radical and turn it into a fractional exponent. So that's a 5th root of e. So to write that as a fractional exponent, that would be 1 over 5. So remember, radicals can be turned into fractional exponents by putting the index to the bottom of a 1, okay? So writing it like this way, it's easy to tell that my answer will be the 1/5, okay? But y'all, I'm going to show you how to punch in a 5th root on the calculator. So on this problem, let me go to my calculator. So I would hit my ln first. Now this was the 5th root of e. So anytime you're doing a root that's higher than a 3, you got to punch the root first. So I'm going to punch my 5. Then I'm going to hit math. And I'm going to go to option 5, which has that x in front of that radical. But y'all watch what happens when I hit that number 5 and hit enter. It puts me a 5th root up there, okay? So cube root, we got an option for that. But a 4th root, 5th root, 6th root, or anything else, you hit the number first, and then you get the one that has the x in front of the radical. All right, under here I have an e. So since I'm just doing the e by itself, I'm going to hit second divide. All right, y'all watch this. I'm going to get a 0.2, but remember, turn 0.2 into a fraction, and you get 1/5. That's what's nice about that calculator. It can do all these problems. You just got to know sort of where to go to put them in, okay? All right, so now let's look at this next thing we're going to learn is converting. We're going to convert between logarithmic and exponential. Okay. So the property that allows us to do that says log base x of y equals b. I've got a two-sided arrow. This two-sided arrow means if and only if x to the b equals y. So this is the logarithmic form. This is the exponential form. So notice, the base of the logarithm equals the base of the exponential. The result of the logarithm equals the result of the exponential. And then the exponent of the log equals the exponent of the exponential. So watch how I convert back and forth on these, because this will help us solve equations when we come in next Tuesday. So this Thursday, we'll learn properties. And then next Tuesday, we'll start actually solving equations. So for these next few examples, they want me to convert to logarithmic equation. All right, y'all. So 17, I got 10 to the fourth power equals 10,000. So to convert it to a logarithmic, I need to first start with my log. I then need to figure out the base of my log. Well, remember, in exponential, the base is the x, so that becomes the base of the log. So I have a 10 in place of the x. So 10 will be the base of my log. The result of the exponential becomes the result of the logarithmic. Well, the result is the 10,000. So I bring down my 10,000 as the result to my log. And then that's going to equal the exponent. The exponent of the exponential becomes the exponent, which is the answer for the log. So that's going to be the 4. Okay? That's all there is to it. Put piece by piece what goes where, okay? 18 has 243 to the 1/5 equals 3. All right, y'all. So once again, write down log. The base of the log is the base of the exponential, which is the 243. The result is the result of the exponential, which is the 3. So a log base 243 with a result of 3 gives me the exponent of the 1/5. Oh, y'all, how about this? E to the 5th equals R. All right, so I'm going to write my log. My base is the E. My result is the R, and that's going to equal the exponent of 5. Now, y'all, we'll say this. MathLab would take this in another form. Since this is a log base E, I could write this answer as a ln of E. Whoops. My bad. How about the ln of R equals 5. So remember, ln is really a log base E, so you can replace that with the ln and then bring down your R, and that equals 5. So MATLAB would take this one either way, okay? All right, now 20 P to the K equals 81. So then they start throwing just random letters at you to see what you'll do with this. So let's write down log. Our base is the P. Our result is the 81. And that's going to equal the exponent of a K. So y'all, like I said, this is just to get you good at rewriting. So now we're going to rewrite the other way. We're going to go from logarithmic and we're going to convert to exponential equations. So 21, I got a log base 5 of 125 equals 3. So they're giving us the logarithmic form. We're going to write it as the exponential. So notice, x is the base of the log. Well, the base of my log is 5. B is the exponent. Well, B is the exponent on the log would be the 3. So that means 5 to the third power equals 125. Okay, y'all try this one. Let's see. How about this one? This one's going to be a trickier one. Log of 0.1 equals -1. So y'all, the thing that makes this one tricky is there's not a base down here. So remember, anytime you got a log and there's not a base shown, that base is automatically a 10. So my base is a 10. My exponent is -1. So 10 to the -1 gives me a result of 0.1. Okay, that's the thing you got to remember. Missing logs are automatically 10, okay? All right, y'all. ln of 52 equals 3.9512. So remember, this is the ln. ln is really a log base E, which means my base is the E. My exponent is 3.9512, and that's going to equal my result of 52. All right, then one, they're going to throw the alphabet at us. So here we go. We got a log base M of a capital T equals -y. Base is the M. Exponent is the -y. And y'all, M to the -y equals my result of T. Okay, so you'll see why we learned this next week when we're solving equations. Because usually to solve exponential, I turn them to logs. And to solve these logs, I'm going to turn them into exponential, okay? All right, y'all. Around 25, they start wanting us to use the calculator. Now, on these ones, the reason we're using calculators is because these aren't what we call perfect squares and cubes and stuff. So when the numbers aren't perfect squares and cubes, you get never-ending decimals. So they want us to use a calculator, and they want us to round these 4 decimal places. So for the first ones, I'm going to use the calculator to find the common log. And then I'm going to round it 4 decimal places. Now, remember a while ago, we said the common log is a log base 10. Okay, so I'm going to use the log that's on front of my calculator for these. So 25, they want us to figure out the log of 64. Now I'm using curvy equal signs because I'm approximating my answer to 4 decimal places. So what I'm going to do is go find that calculator. And y'all, right on front by the 7 is my log button. So I'm going to hit log and then punch in my 64 and enter. Now they want us to round 4 decimal places. So that'll be a 1 point. So let's see, I got an 806. The 4th number is a 1, but it's got a 7 after it. So the 1's going to turn into a 2. So I get 1.8062. Okay. All right, 26, they got a log of 2. So let's round that 4 decimal places. So we'll go find our calculator again. Log 2. And y'all, I doubt we're doing this kind of stuff in our head. So you got to have a calculator for this part of this class, okay? Because we just can't do logs in our head. So the log of 2 gives me 0.301. So the 4th number is a 0, but it's got a 2 after it. So we're going to keep that a 0.3010. All righty then, one more of those, and then they go to the LN stuff. So how about the log of a negative 36? Now here's one of them negative x's when I was looking at the graph and I said, well, I can't do negative x's. Well, here's a negative x. Remember, this is a log base 10. And this is trying to find me the exponent that would raise that 10 to turn it into a negative 36. What do y'all think about this? There's no exponent. There is no exponent that I can put right here that'll make that 10 equal a negative 36. Because exponents don't have the power to change the signs of anything. So look what the calculator is going to do on that. I'm going to hit my log. And I'm going to punch in a negative 36. And when I hit enter, the calculator says error, non-real answer. That means, ooh, excuse me. That means that we cannot do this in the real world. And if I go to and hit enter, what's it? It's telling me, hey, this negative 36, we cannot do that, okay? So what we put in place of that, Math Lab, since you can't take the log of a negative, since you can't take the log of a negative number, we say that this does not exist. Okay, nothing I can do to a 10 to make it a negative number, okay? All right, so that was getting us used to the common log. Now they want us to use a calculator. To find the natural log. And I'm going to round these 4 decimal places. Hey, off of 28, I got the ln of 53. So remember, ln is my natural log. And y'all, the biggest thing in Math Lab, when you're writing this, that's not an I. That is the LN. When you punch it in Math Lab correctly, it'll make it dark and bold, okay? Not on this one, you won't have to do it, but I'm just letting you know, like on some of those where we were converting back and forth, that's actually an LN, not a IN, okay? All right, y'all, so LN is on front of that calculator. So let me clear everything out for us. Now, if you notice on the calculator, you can actually tell that's an LN, okay? So LN, punch in my 53. All right, y'all, so let's hit enter. So that looks like what, a 3.970. So the 2's in the 4th spot, but it's got a 9 after it. So we'll make that 2 a 3. So that's going to be 3.9703. Okay, 29, ln of 0.25. So if I went to my calculator and punched that in, that would give me, so I'm going to show y'all what this one does. Because that 0.25 is less than 1. So here's my ln, 0.25 once I hit enter. Because that 0.25 is like a fraction, like 1/4. That's why we're getting a negative answer on that. We get negative 1.386. We're going to round that to a 3. Okay, so one more of those, I think. Let's see. 30 is the ln of a negative 1.19. All right, remember, this is a log base E. But guess what? There's nothing I can do to this E as far as exponents go that can turn that E into a negative number. So y'all, once again, I got that negative number sitting here. As a result, so there's nothing I can do to a positive number to make it a negative answer. So this one does not exist. So I can't take the log of negative numbers. I can't take an ln of negative numbers, okay? All righty, then towards the end here. Now, this was old school methods before we had the nice calculators. But back in the day, they wanted us to use what we call change of base. So find the log using, so log is short for logarithm. So find a log using change of base. So before they used to put that log base function into the calculator that's under the math command, we had to do what we call change of base. So change of base is this little formula. If I have the log base A of B, in my calculator wasn't letting me put in this kind of base because it didn't have that option back then. Change of base meant we took the log of the B and divided by the log of the base A. So I could use the log on front of the calculator doing this change of base, where I took the log of the result and I can divide by the log of the base, and it gives me the same thing that you get when you use the log base in the calculator, okay? So let's try 31 and see what we get. Log base 6 of 18. Now I'm going to show you both ways. First way, using the change of base, the old school method, I would take the log of 18 and I would divide by the log of 6. So y'all going to do this both ways just to show you what I would get on that, okay? All right, so let me start out old school method. I would do the log of 18. So hit log 18, close parentheses, and then divide by the log of the 6. So notice I get 1.6, 131. And watch what happens when I use the log base. So I can hit math, go down to log base, hit enter, punch in my 6, my result of 18. And y'all look here, I get a 1.6131. Same answer. Y'all, what's even cool when I use the change of base, I don't have to use the log both times. I could use the ln both times. Watch this. I could do a ln of 18, close parentheses, divided by the ln of the 6, close parentheses. And look at that. I still get the same answer. So change of base, don't matter what base you use. You could use the log base 10s, the common logs, or you could use the log base e's, the natural logs, but it has to be the same one for the top and bottom, okay? But like I said, y'all new schools, I would just go to log base, punch in that stuff, and hit enter, and be done, okay? All right, y'all, then the last thing they'll do, they'll have you graph just so that y'all can look at the graphs. So the last few problems, they'll say graph f of x equals 2 to the x, and then they'll want us to graph the inverse, which is the log, and let me see what they had on that. On this one, they have a log base 2 of x. So I would put this one in y1 and this one in y2. So y'all, let me go to my calculator. Now, if you remember, we sort of know what these are going to look like, because when I was talking about the graphs, I showed you pictures of both of these. So let me go to y equals and clear that. So first I'll put my 2 to the x. So 2 exponent x. Then I'm going to come down here to y2, and I'm going to put log base 2 of x. So remember, to get log base 2 of x, I'm going to hit math. Go down to log base, hit enter. So my base was a 2, and my result is those x's. All right, so I got my y1 is 2 to the x, y2 is log base 2 of x. Y'all, when we hit graph, there's my exponential, there's my logarithmic. Now, I'll show you why we like that new calculator. Let me show you that. Let me switch my calculator over. So y'all watch this. I'm going to go to what I have first, 2 to the x. And then let me go down to y2, and I had let me go to math and get that log base. And that was log base 2 of x. So let's see, my exponential function is going to do what? Sort of blue, and the other one is going to do either red or orange, whatever that is. So when I hit graph, there's my exponential, there's my logarithmic. Oh, y'all, so that's the last thing. They just want y'all to see that exponential graphs and logarithmic graphs are inverses of each other. All right, y'all got any questions on this? All righty, so I'm going to quit recording this thing. If I can get that sent out to us in a little bit.